All right, here's the final video over partial fractions. We have this last little monster to work through. It should be similar to number 3, but I think this one's actually easier. It cleans up a lot easier. At the beginning, it looks worse, but hang in there. So first off, I see 2 factors. We have x squared plus 1, and we have x squared plus 1 squared. So kind of similar to number 2. Think if I had one of the factors, what would I need to multiply by to get the rest of the denominator? Or, to get this factor, if I just had a 1 in the denominator, what would I need to multiply by to get that entire denominator? So that's the idea with those 2 factors right there. That means we need 2 fractions. And if you worked number 3, you see that we have quadratic factors. That means we need linear numerators. So we're going to have x squared plus 1, x squared plus 1 squared. And since those are quadratic, I need to write something linear up top. Or another way to think about it, since the denominator has a power of 2, this needs a power of 1. It needs to be down 1 exponent. All right? So likewise, let's keep going in the alphabet. We have cx plus d. We have 4 variables. Don't freak out. It actually works out very nicely. So we need to multiply the entire equation by the original denominator. And watch, it cleans up very nicely. All right, I paused that so you didn't have to watch me write every bit of it. If you need to hit pause and catch up, go for it. So now we cross cancel. So that crosses out, that crosses out. Look at the last one. That crosses out, that crosses out. The middle one isn't as nice. That crosses out and only one of them crosses out. All right, let's write what's left. All right, we have ax cubed plus bx squared plus ax plus b. You had to FOIL that out. And then we have the last one, cx plus d. All right, so if you need to rewind and you want to FOIL this out, that times that, that times that, that times that, that times that. That's how I got those 4 terms. All right. Now you organize it into a system. So we have the x cubed terms. And look at that. That means 5 equals a. There's one answer right there. That works out pretty nice. We have that equal to that, and there's another answer. Had to look at it for a minute. Let's see, I need another color. What do we not have yet? Let's do triangles. We have that equal to that and that. We have to do a tiny bit of math. All right, last one. I haven't used orange yet. Let's use orange. And what shape? I'm out of shapes. Underline. How about that? So we have -3 equal to b plus d. And this should go pretty quick because we already have a and b. For C, let's plug in 5. And we see that C is 2. For D, let's plug in -3. And we see that D is 0. And this right here is a perfect example of how, because of that, this up here was not necessarily CX plus D. It's just a CX. I don't know if that makes sense, but when I first learned this, I doubted that process. But yet, if one of those values is 0, then it just gets ignored. I don't know. I don't know if that makes sense. But final answer is 5x minus 3 over x squared plus 1 plus 2x over x squared plus 1 squared. And that's it. Hope it made sense. See you later. Bye.